Hi everyone and welcome to What on Earth. When we take videos of certain things with our cameras, like TVs, there's often this weird flickering. Today, we'll explore why. First you'll need to understand something about how video cameras work. There's no such thing as continuous shooting. Instead, they shoot what's called frames. Any video is basically a series of frames, or still images, shot very fast, one after the other, and played back with only milliseconds between them. The human eye and brain can't tell the difference at that high speed, so instead of individual still images, they all blur together into what looks like a continuous scene. You might think, hey, that's cheating, the world is actually continuous, and you could have a point, but that's actually how our own built-in visual system works anyway. These frames have to be played back at a certain minimum speed in order to seem smooth. Too slow, and we spot the trick and see them as still images. The minimum is about 24 frames per second, which is what the old film cameras use. So each frame is on the screen for 1/24th of a second, or 42 milliseconds. Just to be safe, and to make the quality look better, standard videos these days are often run at 30 frames per second. That's where the acronym FPS comes from, frames per second. Okay, so that's how long the frame is displayed on the screen, but is the camera exposure the same length of time? The answer is usually no. How long the shutter is open, exposing the film, is determined by the shutter speed. You can vary the shutter speed to get sharper or blurrier images. The usual default setting is for it to be half the length of the frame, so in the case of 30 FPS, the shutter would be open for 1/60th of a second. Now if you want a decent look at something that happens really fast, like an explosion, you have to use a high FPS camera. To give you an idea, I've worked with cameras that go up to 1200 FPS, but the really expensive ones can go up to a mind-boggling 130,000 FPS. There's a fantastic video by SmarterEveryDay using this technology, which I'll link to down below. Part of the problem with high FPS is that because the exposure time is so short, there really isn't a whole lot of light getting in, and so if you're not careful about your lighting, the video is too dark to even see anything useful. And you can't use normal light bulbs to help improve the lighting either. That's the other problem I encountered when using high-speed cameras. If you try a light bulb or a fluorescent tube or anything else that's on AC power, then you get a horrible flickering in your videos. And that brings us back to our original question, why the flicker? Say you saw a TV ad or a show that you really liked and wanted to record. You got caught unprepared, and there's no time to set up proper recording, or maybe you don't have the equipment in the first place. So you just whip out your camera and point it at the TV. When you play back your video, there's an annoying flicker that totally ruins the video quality. Well, if you remember, the TV is playing at a set frame rate, probably 30 FPS. Every 30th of a second, the image on the screen fades away and gets replaced by the next one. Now your camera is also recording at a set frame rate, probably also 30 FPS, and it's quite unlikely to be perfectly in sync with the TV. So, sometimes your camera catches the TV frame just as it's fading away, which causes that flicker which annoys you so much. This really applies to the old CRT TVs, the cathode ray tube ones. If you do a bit of experimentation, you find that it doesn't really happen with the LCD models. The underlying technology is different. The modern ones aren't based on electron beams scanning back and forth. Then there are helicopters. When you have a film of a helicopter, you sometimes see the blades either flickering weirdly or rotating very slowly. You can even, as in this video, see them staying perfectly still. That's impossible, you say. Helicopter blades spin round extremely fast, anything up to 500 rotations per minute. Well, yes, they do, but that is the magic of frame rates. The camera only takes a picture every 30th of a second. Now say the helicopter rotor has 4 blades, rotating at 450 rotations per minute. That's 7.5 rotations per second, which is a quarter of a rotation every frame, or 90 degrees. So, in one frame, the blades are here. In the next frame, after a 30th of a second, they've moved 90 degrees to here, which looks like they haven't moved at all. The frame rate is perfectly synced with the rotation rate, and that's exactly what these people have done here. Full credit to these guys, I've put a link in the original down below, and I don't think I'm stealing their thunder, more like spreading their fame. Thanks for watching, and remember to spread the science.